Hey YouTube, DeVore here again, and today we're going to talk about the 2.2 task in the Math 3 Mathematics Vision Project textbook. This task is called Falling Off a Log, and it's about graphing logarithms. Now this is something that if you're coming from a traditional Algebra 2 background, I find that graphing logarithms takes a back seat until you hit pre-calculus. Not so much here, which is definitely a good change. So first thing we're going to do is we're going to graph some very simple logarithms. So it says to construct a table of values and a graph for each of the following functions. Be sure to select at least two values in the interval 0 and 1. So we need a couple fractions. All right. So we're going to have x and f of x. Now we need a couple values to start with. Remember that when we're putting in logarithms, we're thinking about powers of 2. So we've got 1, 2, 4, 8, and looks like we can do up to 16 on here. So let's go ahead and do that. And that says we need a couple that are smaller. So let's do 1/2, 1/4. And then remember that our answer is the exponent that goes with it. Usually the easiest one to start with are the non-fraction numbers. So we've got 0, 1, 2, 3, 4, and then -1 and -2. So here's our graph. And we are going to just start graphing some points. Let's see, we've got 1, 0. I'm going to graph the ones up here first, and then I'll graph the negative ones, just because I said so. Okay, 2, 1, 4, 2, 8, 3, 16, 4. Okay, 1/2, approximately 1/4, approximately. So let's go ahead and start kind of drawing the curve. Let's see how well I do. Oh, hey, I didn't do a terrible job. Okay. One thing to notice is that there is actually a do not cross line here, right here, at x equals 0. Because remember that we can't have any negative numbers as our input. We also can't have 0. So this line right here we call an asymptote, the thou shalt not cross line. And we're going to come back to this. This is really important. On each of these graphs, I'll make sure that I draw it in. Okay. So now we have log base 3 of x. Let's make our little table of values. And remember that we are dealing in powers of 3, including negative powers. So 1/9, 1/3, 1, 3, 9, and we can't go any higher than that. -2, -1, 0, 1, 2. So this one's got fewer points, but that's mostly because our x coordinates only go up to 20. Our next one up would be 27, which we don't have room for. We're gonna have to just go with the ones we have room for. 3, 1, 9, 2. Now 3 would be over here at 27. And then we have 1/3 and 1/9 is going to be like really darn close. We're going to pretend that that's not actually on 0. We're going to pretend here. So let's try that again. I didn't do a good job. Better. Okay. Now, it's not actually flat. We're going to agree that it's not actually flat. And then our asymptote is right here at x equals 0. That's our asymptote. Okay. Next one. We're looking at powers of 4. So we've got 1/16, 1/4, 1/4, 16, -2, -1, like that. And sometimes I find, especially when you're getting started with logarithms, sometimes it's easier to think about what we would think of as the y values first, because those are our exponents, and then using that to generate the x values. So you're taking advantage of the fact that this is an inverse function of 4 to the x power. I've just been doing this a long time, so I can just go ahead and pop these out without too much issue. If you need to go from exponents to powers and then just swap, take the inverse, that's totally fine. You'll want to eventually get comfortable with just doing it as is. But for right now, especially as you're just getting started, it's not a terrible way of doing it. Okay, let's see if I can do this the first time. Okay. Ooh, I think that was even better. And once again, asymptote. Okay. So once again, the asymptote. Now, they give us the function here. We're not actually going to graph it because it gets our x values get so big so quickly that it's just not even worth it really to graph it. So let's just go down here to some of these thinking questions. How did we decide what values to use for x in your table? We used powers of the base. How did you use the x values to find the y values in the table? So if we have it in the form, kind of in a general form like this, b to what power equals x. That's really what we're going for. The what power is really the answer to our question here. What similarities? Well, there's a couple big similarities. For one, they all have the same x-intercept. If you go back to your graph, they all have an x-intercept. Add 1, 0. So they have a similar shape. Same x-intercept. Same asymptote. The major differences is this is how I wrote it. So you're looking at where y equals 1. X is the base of the logarithm. Now what I meant by that, let's look back up at the graph. When we have here at y equals 1, x was equal to 4, which is the base of our logarithm. And then that comes back to kind of our other identity that we found in 2-1, just kind of manifests itself in this case. What is the effect of changing the base on the graph of a logarithmic function? So the larger the base, the slower the growth. And we talked about this very briefly in the 2-1 task right there at the very end, where I gave some examples using log base 2 and log base 3. That can be shown in these graphs here. I mean, if you notice, here's 2, 3, 4. See how it's getting closer and closer to the y-axis? The bigger that base gets. So it's growing more slowly. All right. So I actually we're not actually gonna graph these. You can graph these on your own if you would like. I'm just going to give you some of these. So here we have a plus a logarithm. We could also have minus, so a can be negative. So a is what we call a vertical shift. So you move the graph up or down, so vertically, a units. And if you want to move it up, a is positive. If you want to move it down, a is negative. Pretty simple. Okay. How do you predict that if we're going to be adding it inside the logarithm? Now this is called a horizontal shift. So instead of up, down, it's side to side. And it's a little counterintuitive here. The effect of adding b it's, in particular, we're moving over the asymptote. So if we add b, we are shifting to the left b units. And if we subtract b, we are shifting to the right b units. So it's a little counterintuitive. We're really doing the opposite of what it's saying. If we're adding, we're going more negative. If we're subtracting, we're going more positive. A little bit counterintuitive. Okay. So we're going to do a couple of these. We have some graphs that we know are transformations of log base 2 of x. And we're going to be looking at the graphs, trying to figure out how they were shifted up, down, left, right, and generate some equations. First thing that you do whenever you have one of these functions and you see that's transformed, always find the asymptote first. So our asymptote is at x equals -3. Now remember that our asymptote makes it so that whatever we have, let's see, I'm just going to write it like this. Whatever we have on the inside, this is a little more typical, using minus on the inside as opposed to plus. You want this inside right here to be equal to 0 at -3. So let's go ahead and solve. X minus b equals -3. That's really, oh, sorry. So, sorry, -3 minus b equals 0. We plugged in -3 for x. So that means that b equals -3. So here's the first part of our little function here. Log base 2 of x minus -3 plus a, or if we rewrite it properly, we have x plus 3. So you might notice that here we have +3, here we have -3. If you don't want to go through all of these steps, you can always just say, oh, just take this and change the sign and pop it straight in and you're good, basically. All right, now I need to figure out if it got shifted up or down. The way we figure that out is we look there. We're going to use this as our point of reference. So we're going to make a little table of values here. So here's how I like to make these. I have x, I have x plus 3, then log base 2 of x plus 3. Okay. So I'm gonna, let's see, that's a negative 2. Negative 2 plus 3 is equal to 1. And then we have log base 2 is 0. Now, something else that I know, really what I'm asking here is log base 2. I know that that's what it's supposed to be. So there is actually no vertical shift at all. My actual equation here is, looks like that. All right, the next one I know that there's a shift, so this is going to help us out a little bit. Here we have our asymptote, asymptote at x equals 2. Means right off the bat, I know that I have x minus 2 plus a. So you get half of it for free just by doing it this way. Okay, so let's look at I like to just use this point. It makes things easier. So we have x minus 2 log base 2 of x minus 2 and then log base 2. And you'll see why I'm doing all this just here in a second. So let's see, my y value here is 6. And let's see, the y value is 0. Now, when I plug in x, I really have x minus 2, which is 6 minus 2 is 4. And now I'm going to look. I'm actually going to plug in this number right in here. So I have log base 2 of 4, which is 2. So here's what my y value is for my function. Here's what it actually should be based on my on the actual number that I'm plugging in. And you notice that I have to add 2 sorry, not add 2, I have to subtract 2 to get to where I need to go. So that means that I am shifting my whole function down. I end up with log base 2 of x minus 2 minus 2, like that. And there we're done. Okay, so now we need to do a couple little graphs here. Okay, first thing, if I have my, it says x minus 1, that means I have an asymptote at x equals 1. So let's just boop, 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 like that. Okay, now I need to figure out a couple of points. Some of the easiest points, I'm going to make a little table here again. And there should be one more on here, but we'll do that part together. Okay, so what I really want is I really want this middle column to be my powers of 2, because that's actually what's going into my function kind of as a block. So I really want, I can't do 1. So I would really like it to be 2, 1, 2, 4. And maybe we can do 8, we'll see. So I end up with 0, 1, 2, 3. Now this isn't my actual x value, this is x minus 1. So I need to figure out something minus 1 gives me 1, gives me 2, 3, 5, 7, like that. So let's go ahead. These are my x values now. And the reason why I said we needed one more column is because we have this plus 2 on the outside. But we can do that part. So I have a point at 2. 0 plus 2 is 2. 3, 3, 5, yeah. And then 5, 4, like that. And then we can just kind of blink, kind of sketch it like that. All right, got one more. They really don't give us enough room for these. Okay, so we have x plus 2, which means that my asymptote is at x equals -2. So boop, 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 like that. Then we have x plus 2 log 2 x plus 2. Okay, so I want this once again to be 1, 2, 4, and 8, which means that this should be 0, 1, 2, 3. Now if x plus 2 equals 1, that means that this is -1, 0, something plus 2 gives us 4, 2, and then 6. Okay. So once again, these are our actual x coordinates, and then we need to take our y coordinates and we need to subtract 1 for them. So -1, 0, 0, 2, 1, and 6, 2. So we go. Whee! Oh, that was terrible, but it'll work. All right. So there's our little graphs here. Now it's asking us to compare the transformation of the graphs of logarithmic functions with the transformation of the graphs of quadratic functions. If you remember way back in quadratics, you had this form that looked a little something like this, where h and k is the vertex, this vertex form. You remember that if you change these numbers, it moved the graph up and down. So this is our, once again, this is our horizontal shift, and this is the vertical shift, just like we did before. And this is also the reason why I do minus, whereas they for some reason do plus when they gave it to you initially, because minus matches what you have in point slope form for linear functions and vertex form for quadratic functions. So it's the same idea, just written a little bit differently. We will be returning to this pattern a lot here in the next year, all the way through Module 7. So I hope you like talking about horizontal and vertical shifts. All right, so that was the 2.2 task in the Mathematics Vision Project Module 2 in the Math 3 textbook. Hope you guys enjoyed. If you have any questions, please feel free to send me an email and I will answer you as best I can. If you like these videos, please remember to like and subscribe. I hope to see you guys in the next video. Have a great day. Bye-bye.